Alright guys, so I wanted to look at this problem today because it's one that I found a little more challenging and I had to kind of think about a little bit, and there's a lot of different ideas that are going into this. So if you haven't read it yet, pause the video now and read through it. Now at this point I'm going to talk through various parts of this so that we can really understand what's going on. Okay, so we've got a discrete random variable x which has a geometric distribution. Now remember, in a geometric distribution, x represents the number of times you need to do something until you win. Okay? Now the probability here is 0.03. Now by win I mean that you have success, right? So we keep doing something, there's a probability, initially unknown probability, that we're going to attempt this thing until we get a success. There's and what we're going to test is the null hypothesis of that probability is 0.03. So 30% of the time we're going to have success. But that means that most of the time we're going to have to try it again and again and again, right? And so the repetitions, however many times we have to repeat it, that's what x is for a geometric sequence. Geometric distribution. Now, next it says that a random sample, and it goes from 1 to 10 of independent values is taken from x. So we're going to have 10 different situations where I keep doing whatever this is until I have success. So in the end I'm going to have 10 individual successes. Alright? Now it says the critical region is defined as, from I equals 1 to 10, the summation of xi. And then it's less than or equal to 18, union with greater than or equal to 55. So what we're saying is that we have some kind of distribution. What it really looks like, if it's normal, not really important right now. Probably not normal because it's geometric distribution, and we'll talk a little bit more about what that means later. But essentially we have some kind of distribution where, you know, if I were to have success on the first try every time, then it would be 1 plus 1 plus 1 plus 1 all the way up to 10, and I'd have a sum of 10. So it's asking me to add up how many total trials did it take to then have those 10 samples that ended up having 10 successes. All right? So essentially, if we are looking at it as a normal curve, then our critical will be 18 and below, so all of this will be out, and then 55 and above will be out. Those are the values. If I'm able to complete x in 18 or less, then that means I need to reject my null hypothesis. If it takes me 55 trials or more, then I also need to reject the null hypothesis. Anything in between those two we're saying is acceptable. We have to accept the null hypothesis. Even though it might not be true, we're still going to accept it because there's not enough evidence to reject it. All right? Now remember, this is the summation of all of those x values, so the total number of trials needed to get those 10 successes. All right? So for which values of s equals the summation from 1 to 10 of x will the null hypothesis be accepted? Well, if it's being rejected from 18, below 18 and equal to 18, then that means from 19 all the way up to 54 we're going to accept. This is discrete. There's no way to get anything between 18 and 19. And so you could simply state that those are the values. From 19 to 54 are the ones that will be accepted. All right. Now on letter B, it now asks us to state the distribution of S. Okay. Well, if X is a geometric sequence, I keep saying sequence, a geometric distribution, which means I have to do it until I get that last one, then the summation is going to be a negative binomial. Okay, now the reason why is because as I add those together, the final one has to be a success, right? It doesn't really matter how many, I need 10 total successes, and the final one has to be a success, because if the final one's a success, that would be the last part of x10. I'm not going to do any more trials after that. Okay, so what I'm going to end up with here is a negative binomial. All right, so S is a negative binomial where I need 10 successes, and the probability of a success is 0.3. Now, within that, it really doesn't matter where those successes come. right? The first 9 can come in any order. It doesn't matter how long it takes because that's x1, x2, x3, x4, all the way up to x9. The important thing is recognizing that that last one does have to happen at a specific point in time. Okay? So now we've got the distribution, which will be a negative binomial distribution. It now asks us to define a type 1 error. Okay, well, that's not so bad because a type 1 error is, of course, when we accept the we reject the hypothesis. Yeah, simply. When we reject the hypothesis when it's actually true. Okay, well, looking at our distribution, right, anything under this distribution could represent a true null hypothesis, but we are going to reject it if it's below 18 or, equal to or below 18 and equal to or above 55. And so, therefore, the next one is calculate the level of significance for that test, which we'll do in just a second. But ideally, we know that the type 1 error is just that we reject it. So in other words, probability of a type 1 is equal to the probability that S is less than or equal to 18 and S is greater than or equal to 55, given that the hypothesis is actually true. So that's kind of looking at the probability. This right here is really the statement we're looking for. The type 1 error is that it's less than that or greater than that or equal to, given that H0 is actually true. Okay? Now, the next step is to calculate the level of significance. Okay? So what I'm going to do is rather than writing the whole thing out while you're just kind of listening and waiting, I'm going to go ahead and pause the video. I'm going to write out the equation that we're going to use, and then I'm going to talk you through it so that we can understand what's going on. All right? So here we go. All right, so here it is. Now, what we're looking for is the level of significance. Now, to get the level of significance, we're really looking at the probability of a type 1 error. So that's, the percentage of this stuff out here. Now, again, we're not looking at a normal distribution. We're looking at a negative binomial. Okay, so that's the formula that we're going to have to use. Now, you'll kind of recognize some of this as being the negative binomial formula, but you may or may not notice it given all the numbers already put in. So let's go ahead and look at, I'm going to go ahead and write out the negative binomial distribution, which looks like this. It's x, and then, when we write the probability, it'll be x minus 1, r minus 1, p to the r, q to the x minus r. Now remember, this is how to get a probability of a specific event. All right? So what we're going to look at here is we need to calculate the probability of all the events being 18 or below and all the events being 55 or above. Now, this right here won't necessarily sum up from 55 up to infinity. But what it can do is it can do everything from the bottom to 54. And if we take that and we subtract it from 1, then that will give us the 55. So let's look down here at the equation and hopefully we can make some sense of it. Okay, so what I'm doing first is we're finding the summation from I equals 10 to 18. Now 10 comes from the fact that as a minimum, it's going to take me 10 trials. Even if every single one is a success, right? Thinking back to our original problem here. Even if every single one is a success, whatever's going on here, it's still going to take me 10 individual attempts to be able to get 10 successes, right? Now I want this to include up to 18. And so remember, 18 is part of that critical region, which is going to be part of the rejection, which therefore is part of our significance. All right, so we're going to go from 10 to 18, and we're going to add up all the possibilities, right? So we want to do x minus 1, r minus 1, p to the r, q to the x minus r, just like we have over here. And so it's going to be x, which is I, minus 1 over r minus 1, but r is 10, right, because I want 10 successes. And then I got 0.3 to the 10th, 0.7 to the x minus, again, 10, because that will then add up all the probabilities from 10 to 18, that I'm going to get it after 10 trials, 11 trials, 12 trials, and so on and so forth up to 18. Now, that's the easy part down here. Now I need to be able to get this part up here at the top, looking at my distribution. I need to, oh, that shouldn't have gone away. I do need this section up here at the top. And so in order to get that, I'm going to have to do 1 minus the 54, which is what we were talking about before. So I'm going to do a similar thing. I'm going to sum up again from 10 to 54. I can't do the other side because there's no, well, I guess you could technically go to infinity, but your calculator is going to have a hard time dealing with infinity. Your results will be better if you go from 10 to 54. Again, 10 is the minimum, right? So up to 54. Now 10 to 54 would cover everything to the left of 55. And so similarly, we've got the x minus 1 over r minus 1. Again, r is 10 because I need 10 successes, times 30% to the 10th power times 0.7 to the x minus 10, because that'll take care of all the non-successes. And so therefore, when I work all this out, then it should give me the final answer. Now, you should be able to do that on your calculator. So what I'm going to do again is I'm going to pull up my calculator so that I can show you the answer, and you'll see the keys that I pushed, but I'm not going to go through the whole process because the calculator is a little bit slow. All right, so I'm going to go ahead and pause it, bring up the calculator. Okay, so I've got here the key press history just to kind of show you, but this is what your equation should look like right here. Okay, so you can type in the summation. The summation was gotten by alpha F2, and then the summation's on there. And then you can type straight from x equals 10 to 18. You can put in the x minus 1. And then the NCR, remember the NCR is your combination that's covering this first part right here with the number in parentheses there. And then from there you can just type in the powers. Now I only typed in the first part here, and I got a total of 0.020967. If you were to go ahead and type in the other part, which you could do now, if you need to, go ahead and pause. You can try to follow through the keys if you want, but you can kind of see the equation here and what it looks like. Those are the important parts, the summation and the NCR. The rest of it's just exponentials. Again, you can put x minus 10 up here in the power. And when you put those things together, you should get that the level of significance is about 4%. All right? Let's go on to letter C. This one, I think they now say, okay, the true value of P is 0.2. All right? So define the type 2 error. Well, the type 2 error is that we accept the null hypothesis even though the null hypothesis is actually not true. In fact, the probability is 0.2. So this actually says, well, here is the true one. Type 2 then is that we accept 0.3 instead of 0.2. Now again, I'm going to go ahead and pause the video. Try on your own when I say now. Pause the video and try on your own to see if you can come up with how to calculate the power of the test. Now remember that the power is equal to 1 minus beta, beta being the probability of a type 2 error. Okay, so see if you can use the ideas that we just learned in part B to set up that equation. All right, so I'm going to go ahead and work it out, but I want you to pause it now. All right, so I've written my equation down here at the bottom. Let's see if we can go ahead and talk about it just in case you need a little bit of clarification and reasoning on that. Now again, I'm going to go back to my drawing up here at the top. This was what I had drawn for the original distribution with the probability of 0.3. Now remember, it's important to recognize that this is not a normal curve. I just kind of drew it as that because it's easier for my brain to kind of deal with and figure out. Okay, so what we're going to do is we're going to say, okay, well, the probability is actually 0.2, which means probably that the curve should have been a little bit lower, something like this. Okay, now, therefore, the probability of a 2 means that this is actually true, but we accepted this one. And so given that it's true, it needs to be under the green curve here. All right, so given that it's under the green curve, what's the probability that we actually accepted this one, which would be this region, sorry, not there. It would actually be this region in between here. So that's what we're looking for this time. Okay, so this time we'll do it a little bit different. Okay, to get this area, I'm going to take the whole area all the way up to 54. I'm only going to go up to 54 because 55 and up was rejected. So 54 would be an acceptance. And so that's this one. So again, it's from 10 to 54 because 10 is the minimum number of trials, right? That's the minimum if every single one was true. So I got a 10. And then I go I minus 1 over 9. You know what? I completely misdrew this. It should be on the other side. It should be on the other side because with a lower probability, we should have a higher number of x values. I'm sorry, but you know what? It really doesn't change the mathematics. It's still the same idea. But anyway, we're still looking at this region between 18 and 55. And so we'll go ahead and deal with the math the way it is. But this time the probability is 0.2 and 0.8 instead of 0.3, 0.7 because we're using the true curve. We're given that this is true. So what's the probability it's in that area where it would have been accepted? So I go up to 54, and then I'm going to subtract this area right here up to 18. And so the area up to 18 again is 10 to 18 of the same formula there, still negative binomial. And from that point I subtract the 2 and I'll get the area in between those two, which is my beta. And then remember, to get the power of the test, then you just take 1 minus beta. All right? And the answer should be approximately 34%. All right? So there you go. That's the problem. It's a great problem. It puts a lot of different ideas together: the geometric, the negative binomial, the significance testing, type 1, type 2 errors, summations on your calculator, all that kind of stuff. Lots of good ideas and topics here, all getting meshed in together, which is why it's such a great IB question. So anyway, I wanted to share that with you. Hopefully that's been a help.